Welcome to the NPTEL course on mechanical and electrical systems of mining machines. We will be continuing with lecture 19, which is a continuation of lecture 18, that is a power transmission system. It is a part of module 1, that is fundamentals of mechanical systems in mining machines. Now, the concepts that we have already covered is we have understood the power transmission system. Thereafter, we have understood what is the chassis and the function of the chassis. We then understood the clutch plate and gearbox. We also understood the flywheel. Now, coming to the next component, that is the universal joint, and then we will be discussing about the differential gears and the suspension systems in this class. Well, in last lecture I have introduced you to the power transmission that happens from engine to the wheels. So, here it is the engine, that is the powerhouse from which the energy is stored in a component called as flywheel. From there is another component called as clutch, which gets engaged with the flywheel and transmits the power to another component called as the gearbox. Again, the gearbox can be a manual transmission kind, or it can also be automatic transmission kind. From there the power is now taken to the universal joint. We will be understanding what the universal joint is, and then thereafter we have a propeller shaft. So, we will be also understanding the function of a propeller shaft, and then we have another universal joint. Why we have two universal joints also we will be understanding in this lecture, and then we will be understanding the function of a differential, which again transmits power to the wheels. So, when we talk about a universal joint, it looks somewhat like this. It has it looks like a cross, and it has 4 arms which are flexible in nature. It is in form of a yoke which transmits the power from the input shaft to the output shaft. It allows angular misalignment between the shafts. It accommodates vehicle suspension movement. So, there is a cross pin design with 4 bearing blocks, which allows to take the jerks that come from the road, and it does not allow the failure of the mechanical components while the power gets transmitted from input shaft to the output shaft, and it can transmit torque at varying angles as well. So, where it is located? It is located at the gearbox outlet to propeller shaft, and from propeller shaft to the differential input. It is a double U joint for that is used for steering axles. So, here this angle that you are seeing here, they are the flexible angles, and they actually help while there is a circular movement or rotational movement of the propeller shaft, maintaining the angle and the torque that is transmitted from the input shaft to the output shaft. So, now let us see how it helps in maintaining the angle. So, if you see, this is in a form of yoke. So, here this is one universal joint, and here there is another universal joint. In between there is this propeller shaft. So, from the torque that is transferred from the gearbox, it gets transferred to the this universal joint, and this universal joint has the capability to take the load that to take the varying load that comes from the jerking of the vehicle, or due to any misalignment that happens in between the shafts that are connected from gearbox to the differential. So, what is this propeller shaft? This propeller shaft is a hollow steel tube which has the torsional strength. It helps in balancing for critical situations under vibrational loads that come onto the system, and it supports varying suspension angle as well. So, if we see for a truck, so the length of this propeller shaft is around 2 to 3 meters, its diameter is 75 to 100 mm. It is made of alloy steel for higher strength, and the joints it has at both the ends is the universal joints, which helps in conserving the torque that comes from one shaft to the other. Now, while we talk about another important component that is there in this power transmission system is the differential gears. Now, in this differential gear, what do we see? That this helps in transmitting the power at 90 degree, and it also helps in making the vehicle take a turn. So, let us first understand of how this differential is made. So, here let us say this is the from the gearbox and through two universal joint and propeller shaft, the power reaches the differential gear. Now, this differential gear has a, this is the propeller shaft, and from the propeller shaft there is a pinion gear. So, this is the pinion gear. Now, from the pinion gear it is connected to the ring gear. What it is connected to? It is connected to a ring gear. Now, on this ring gear there are this red color component which we call it as the spider gear. Now, this spider gears, they move along with the ring gear, and also they can rotate about its own axis. Now, this spider gears, they are connected to the side gears. So, there are two side gears, one is this green one is the blue one, to which it is connected to. So, now you can see both the green and the blue one, they are rotating at the same speed. For certain duration of this animation you can see both of them, now you can see they are rotating at the same speed. So, while this two shafts are rotating that are connected to the side gears are rotating at the same speed, that is n left is equal to n right. So, this spider gear only rotates the spider gear only rotates with the ring gear. It does not rotate about its own axis. However, when the vehicle has to take a turn, now this spider gear also rotates about its own axis. So, let us say the vehicle has to take a right turn. So, in this case the green one has to rotate at a higher speed than the blue one. So, here in this picture it is the vehicle is taking a left turn. So, that is why the blue one is rotating at a higher speed than the green one. So, let us comply with what is there in this picture. So, the vehicle is taking a left turn. So, my N blue should be greater than N green. So, how it would happen that my N blue has to rotate will be greater than N green. So, here the spider gear has omega rotation, that is along its own axis, and omega spin, that it is spinning along with the ring gear. So, this two components gets added up to give higher speed, higher N blue. So, and there is a difference of omega rotation and omega spin. So, now it is rotating in this direction. So, this is omega rotation, and also you can see there is another component which we call it as a omega spin. So, since it is moving in this direction, so there is omega spin and omega rotation which gets added up for the right hand side. So, that N blue would be like this, blue shaft would be having a higher speed than the green one. So, that allows the vehicle to take a left turn. So, likewise when the vehicle has to take a right turn, so the omega rotation and omega spin gets added up for the green one, and the left hand side wheel would start rotating at a higher speed, and there will be a difference of this omega rotation and omega spin for the right shaft. So, that would slow down the speed that has to be taken by the right hand side, so that the vehicle can take a right turn without skidding. So, this I have already explained how the vehicle takes a turn, where the inside wheel rotates slower than the outside wheel. Well, now coming to the suspension systems of the vehicle, it is one of the most important component which helps in taking the jerks that is coming from the uneven surface of the road, so that the superstructure does not experience the jerking that comes due to the movement of the vehicle and the load that comes from the road surface. So, there are two types of suspension system. One is the leaf spring suspension system, which you can see in the figure herein. So, there are multiple leaves, or there are multiple sheets which are clubbed together to give the rigidity to this suspension system that would take the load that is coming that would be experienced at the central part of this leaves that are attached together to take up the load that comes from the road and is not experienced by the superstructure. So, they have flexible arch design to absorb shocks, and they are standard on heavy duty trucks. So, each leaf is thinner at the end. Why it is thinner at the end? So, that the friction that happens between the leaves can be reduced. So, what is the advantage of this leaf spring suspension system is that it helps in high load carrying capacity, it is durable and reliable, the maintenance is low, and the cost and it is quite cost effective for dump trucks. Well, when you see the other kind of suspension system that we see in our light vehicles, that is we generally see a coil spring suspension system, where you can see there is a coil spring kind of structure which is mounted on each wheels. It is not clubbed together, but there are individual coil springs which are attached onto each wheel, so that they have the required stiffness, so that the jerk that comes from the road surface is not experienced by the patron who are sitting inside the vehicle. So, they give a smoother ride quality. They are compact in design, and they require it's this coil spring suspension system requires dampers, that is they are the shock absorbers which does not allow the shock to get transmitted from the wheel road interaction onto the vehicle. So, there are again certain other kind of suspension system which we see in newer vehicles, that is air spring suspension system, where there are compressed air in rubber billows. What is its advantage? It has adjustable stiffness, which is again depending on the load it can be varied. It has excellent ride comfort, and they are in the premium systems, that is in the newer trucks you would find this air spring suspension system. However, in air spring suspension it maintains ride height regardless of the cargo load. So, they are quite effective in the newer systems. Well, now summing up of what we have already discussed is the complete power transmission system of a heavy machinery, specifically for a dump truck. So, we see there is a engine which creates the rotational power. So, there is a flywheel which stores and smooths the power. There is a clutch which engages and disengages the transmission. There is a gearbox which changes the torque and speed ratios. So, there are U joints, that is universal joints, and propeller shafts which transmits power. There is differential which distributes the power to the wheel at 90 degree, and then there are suspension systems which supports load and absorbs shock. So, if we see specifically for a dump truck, the specifications are for engine, it would be something like 7 to 12 liter diesel engine with 200 to 400 horsepower. The transmission is 8 to 12 forward gears. In manual transmission system, the payload is around 15 to 25 tons, where the suspensions are adjusted. Again, in suspension systems, we see there are multi-leaf springs for taking up the load, and the drivetrain is often 6x4 or 8x4 axles. So, it means how many axles are there in any dump trucks where the power getting transmitted, and then there are air and hydraulic braking systems as well, which increases the efficiency of the power transmission in the heavy machineries. So, the key takeaways from this lecture are the power transmission system efficiently transfers the engine power to wheels. It allows variable torque and speed ratio via gearbox. It accommodates varying vehicle angles and suspension movement. It ensures safe load distribution through differential, and it maintains comfort and durability through the suspension system. So, the dump trucks rely on robust heavy duty transmission systems to handle extreme loads and demanding operating conditions. So, the reference for this part of the study, you can follow these 3 books which you can find it in Amazon. So, here I end the topic. Next class we will go to the tutorial of this topic. Thank you so much.